I'm not sure they'll automatically rotate from mine, but I'll try to keep up. So this is a moon mining mission. It's a mining mission to an asteroid, which would be Amun 3554. It's a Venus intersecting asteroid, so it crosses the orbit of Venus every now and then. It has a pretty low eccentricity, which makes it feasible. It also has, well, its inclination is around 23 degrees, but that's fine as well. We'll be talking about its mining. I have supposedly designed a module for the ESA Odysseus quest competition, and like this is the little handbook. It only treats the mining of Amun being really, really rich. This would be the Amun mining module. Well, an animation of it rotating. Like it's made up of different parts. Like that would be the launcher, and then you'd have the main module and the energy module, and it just left the screen. Obviously, left the booth. This would be the cover for the Odysseus contest, the Odysseus contest submission cover of a moon mining module. I think asteroid mining is really big right now, and we should all look into it. And just I was saying earlier at the chapter talk, like asteroid mining is now just like the way computer industry was in the 80s. Like everybody was scared and didn't want to invest because they didn't properly understand the concept. But everyone who ended up investing went away and got pretty well. Can I hold it?
Oh yeah, you can hold it, but you have to use it otherwise.
Okay. Well, this would be the orbit of Amun as in 2020 when it's really accessible, meaning it has a very low delta velocity, and that's how we analyze if an asteroid is feasible to mine or not, or if an orbit is easy to attain. Like if you have to use, you analyze it talking about the amount of fuel you have to use to get there. And the amount of fuel for Amun is like really low in 2020. It's lower than the one needed to get to Amun. This would be Amun right there. You can see it's a Venus intersecting orbit. That there's a date. The image is courtesy of JPL. It's not too far from the sun. Well, the eccentricity is not that good, but we'll have to do. Once again, it's a mining module. I had the whole thing designed. Like it has antennas, and the really golden thing is Mylar, which we use to coat things, like keep them warm because space temperatures are really, really extreme. Like the ISS has Mylar with apron and captain, but this is just a Mylar surface. Those would be solar panels, since we get pretty close to the sun and we want the whole mission to be feasible and like make money, not consume money. Also, one thing you should know, Amun is full of platinum and gold and rhodium, which are really expensive right now, and platinum is very used in electronics. It's used as jewelry, it's used in hard drives, in displays, and basically if you mine the whole of Amun and then sell all the platinum, you completely crash the market. Like platinum would be less expensive than iron and plastic. So you'd be really big, but in stock, you'd be really, really rich, but in stock actions, not in actual money. The whole mission starts with a network of telescopes. Like you have the telescopes, and then you hunt for certain asteroids, and supposedly that's how you found the moon. And once you hunt for the asteroid, you go, and the telescopes are like multi-purpose, so they're robotic as well. So they can get up a sample and then bring it to Earth for further analyzation, like if you really want to mine the asteroid or not, if it's useful, feasible, if you can crash it on Earth, and so on. This would be the incipient mining module. Some of the mining modules have volatile displays, like you have centrifugal accelerators, and so you can separate the metal and dirt from volatile materials, which you can also use during the mission, like for methane and hydrogen, and how most rockets run on liquid propellants. Okay. If the asteroid is rather large, like Ceres is one of the largest asteroids, probably the largest, also the dwarf planet, you could explore it with rovers. Okay, this is the top mining module. When asteroids get really big and really useful, you have the volatile separators, which would, as I said, accelerate and separate water from oxygen, which you'll further use in liquid propellants, possibly with hydrogen peroxide. Now, why explore and mine asteroids? Well, when exploring and mining asteroids, you might find new materials, which would be incredible. You could get to make metal materials, which could contract instead of float and so on. You have orbital construction advantages. So if you build something in space, it's usually lots less expensive than building it on Earth, since you have microgravity. It's a new source for needed metals. It's extremely efficient. It's really, really visible. I think I might have stayed shorter in some slides and more in others, but this will be an animation of the construction of one asteroid base. That would also be really useful. Like after you mine a moon, you get the sufficient funding to get to other asteroids. And from the talks I've been attending, I understand funding is a really big problem. Asteroid bases may differ. Like if you want to inhabit it, one good thing you might want to do is artificially create gravity. Like in a toroidal example, you could just accelerate it and the centrifugal force will make gravity. You can have communities of asteroid bases. This is getting pretty science fiction. You should first mine a moon and obtain the funding, and maybe your kids will build asteroid bases or whatever. Well, you should consider the mining season, the technical engineering part, like payload, attitude control, power and energy, RTGs, possibly small, like mini nuclear reactors, a pretty big thing right now. Materials, the thermal insulation, radiation insulation, the construction, research. How much time do I have? Okay. Well, I'm like done. This is the last animation. You should orbit first and really study and do lots of research, but that needs funding, and funding can be only be attained after you do the research and mine the asteroid, so it's a vicious cycle. Yeah. Okay, that's mainly it. Very good.